Okay, this is 5.4. First problem gives us this log equation, wants us to solve it. So what we're going to do is use our log properties that are on our formula sheet. We have one that says the log of two things multiplied is equal to the sum of two different logs. So we'll go backwards with that. And we'll take the sum of two logs and make it the log of a product. As long as you have the same base, you can do this. And that equals 2. So then if I change this into exponential form now, it's 10 to the second power equals x times x plus 21. So it's base to the exponent equals the argument. And then I can distribute, and that's 100 equals x squared plus 21x. And I'll subtract the 100 from both sides to get this into a quadratic. And then from here I'm probably going to have to use the quadratic formula unless this factors. No, actually this does factor 25 and 4, so I can make it x plus 25 and x minus 4. And that way my solutions are x equals negative 25 and x equals positive 4. Now definitely double check these in this case because a lot of times they're extraneous. So for example, this has got to be extraneous right here. And I know that because if you stick in a negative number for a log, it doesn't make any sense. And the reason why is because what this is, if you're looking at what this is, set it equal to a variable, you can do base to the exponent equals the argument. Now what you're saying is you're raising some power, some base 10 to a power to get negative 25, and that's not possible. So this will give you an error in the calculator. A log of a negative number you can't do, and this is why. So any negative number that you get is always going to be extraneous here. That means that x equals 4 is our actual solution. All right, the next problem then, find the exact solution to this right here. We're going to try to simplify this if we can. Now we said the sum of logs is equal to the log of the product, so we can make this x cubed times x to the 4th. And then in the bottom we have 80x. Actually, I'm sorry, in the bottom we still have log of 80x, and that equals 2. You might be tempted to use some quotient property here, but that doesn't work here because keep in mind the quotient property is log of x. It's a log of two things being divided by each other. We have a log over a log. That's different. So what I can do though is multiply both sides. So I have in the top, I'll simplify this to the log of x to the 7th. And then that equals 2 times the log x right here. So 80x squared. Okay. So now we can square this. And actually I'm going to bring both sides to base 10. And so these cancel. And I have x squared equals, this is 80x squared, which is 6400 x squared. And I'm just going to move this over to the other side. So I have x to the 7th minus 6400 x squared equals 0. And then take out an x squared. So that leaves me with x to the 5th minus 6400 equals 0. And then I know one of my solutions is x equals 0, which that solution is extraneous. And the reason why is because when you go to stick it back in up here, you can't take the log of 0. Once again, if you're not sure why, because log of 0, what that means, if you set it equal to something, it means you can raise base 10 to some power to get 0, and that's not true. You can't do that. So you can try it in your calculator, it's going to give you an error. So that's extraneous. So there might be a solution here. Let's look for that. X to the 5th minus 64 equals 0, so you can move 64 to the right side, 6400, and take the 5th root. So the 5th root of 6400 is about 5.77, or you can just leave it as the 5th root of 6400. But I'm going to check that up here. So I did that in my calculator, and I'm going to try to plug it in here and see if it works. And it does. I know it's actually really hard to be able to plug this into your calculator and see if it works because you don't want to round it all. So you want to take that decimal that's in your calculator that's not rounded, and you have to cube it and then take the log of it. It's a lot of work, but it's a good practice to be able to try this. You do get 2, and it does work. So your solution is the 5th root of 6400. Okay, the next problem then we have 4 to the x equals e to the x plus 9. I would take the natural log of both sides probably because I know that gets rid of this e. And I can bring the x down, so I end up with x natural log of 4 here, one of our exponent properties, equals x plus 9. And I got to get the x's together because I need to factor them out. So I have x natural log of 4 minus x equals 9. And then I can factor out an x, and that leaves me with natural log of 4 minus 1 equals 9. And then I can divide by this number, natural log of 4 minus 1. And that should give me my answer right there. You can enter that in or try the decimal, which would be about 23.3 approximately. You might need to enter in more decimals than that, but you get the idea. Okay, the next problem wants you to solve this, so we're going to change the exponential form. 4 to the x equals 1 over 512. Now obviously we need to get the same base here. We're going to get an exact answer. So 4 to the what gives you 512. I'm just going to try, 4 to the 4th, 4 to the 5th, 4 to the 6th until I see what it ends up being. Okay, and I wasn't able to get base 4 out of this, so I tried base 2. 2 works, so I'm going to make this 2 squared to the x instead of 4. And then this is really 1 over 2 to the 9th. If you try, it's going to be obviously an integer and not a very big one, usually 10 or less. So there's not that many to try, but I tried 2 to the 9th and that worked. So now I can get both sides in terms of base 2. So I have 2 to the 2x equals 2 to the negative 9, which means that 2x equals negative 9, which means that x equals negative 9 halves is my answer. Okay, the next problem, I'm going to multiply both sides by 5 over 9. And you get log base 3 of x equals negative 35 over 9. And now I'm going to change this into exponential form, so I'm going to do base to the exponent equals the argument. And so this is something I can just do on my calculator, or probably just enter it in like it is, and that should work just fine. Alright, the next problem then wants you to solve this log equation. So what I'm going to do is I'm going to get the 9 to the other side, so I have negative natural log of 5 minus x equals negative 9. Subtract 9 from both sides. I'm going to multiply both sides by a negative 1, get rid of the negative, and then I'm going to change it into exponential form. So an exponential form would be base to the exponent equals the argument. And so there's my answer. I can subtract 5 from both sides and multiply both sides by a negative 1. And that way I get this. And then, you can write that as 5 minus e to the 9th in here if you want. 5 minus e to the 9th. However you want to write it. But there's your answer basically. You can do it as a decimal as well. Alright, this one's a tough one. I'm going to write e to the x plus 7 and I'm going to subtract e to the x from both sides. Get the e's together. Now what I'm going to do is remake this thing. This might be hard for you to see, but if you do e to the x times e to the 7th, that's the same thing. I'm sorry, it's equal 9. And the reason why is because when you multiply like bases, you add the exponents. So it's easier to see going this way. When you multiply like bases, you add the exponents, but it's harder to see going this way. But this is the same equation now, and then I can factor out an e to the x, and I have left e to the 7th minus 1 equals 9. And now I can divide both sides by e to the 7th minus 1, this number. It's just a number. And then I can take the natural log of both sides. If I take the natural log of both sides, this is the easiest way. This comes down and I get my answer, which is natural log of 9 over e to the 7th minus 1. This is something you can type in your calculator, or you can enter it in like it is and get the right answer that way. So the next problem then, I'm going to change an exponential form. Base to the exponent equals the argument, and that was easy because 9 to the 3 halves equals x. There's my answer, 9 to the 3 halves. When you enter that in, make sure you use parentheses. And you could actually simplify this because square root of 9 is 3, and 3 cubed is 27. So this does equal 27 if you do it with your calculator. Do the square root of 9 and then cube that answer. Okay, the next problem I'm going to change into log form. So it would be log base 3 of 2 equals x plus 3. So I changed it into log form. And then you can solve this by subtracting 3. So it's log base 3 of 2 and then subtract 3. So there's my answer. I can do that as a decimal and enter that in, or enter it in like it is. Okay, then the next one's the same thing. I can simplify this one now. By combining logs, it'd be log of x times x minus 2 equals 4. And I can change that in exponential form by doing base to the exponent equals the argument. And then I can rewrite this as a quadratic. So it's x to the 4th equals x squared minus 2x. And I'm sorry, this is e to the 4th. And then I'll subtract e to the 4th from both sides and put it in standard form for a quadratic, which is x squared minus 2x minus e to the 4th. Now I know it doesn't look like a quadratic, but this is just the constant term right here. So I can do the quadratic formula. which is the opposite of b, plus or minus the square root of b squared minus 4ac. That's negative. All over 2a. Double negatives go positive, and I end up with this right here, which I can do as a decimal, and that gives me 8.456 and negative 6.456. Now keep in mind that you want to check these. I can tell you that the negative is going to be extraneous right here. That's going to be extraneous because you can't enter in a negative number for a log. Like I said, you can't take the log of a negative because that'll give you an error. Next problem, we can use our log property to write this as log of x to the 7th divided by x to the 5th equals 2, because the difference two logs is the same as the log of a quotient. That's really the natural log of x squared equals 2, which is e to the 2 equals x squared. If you change an exponential form, so it's not hard to see that x is e, which you could probably enter it in just like that, or do it in your calculator and it's 2.71, whatever. Next one's really tough. I'd probably take the log of both sides and then bring the exponents down. So you'd have 9x minus 8 times log of base 10 of 9 equals 3x minus 3 times log base 10 of 10. Now this cancels to 1, so that simplifies a little bit. And then you got to get the x's together, but in order to do that you're going to have to distribute, so it's actually 9 times log of 9 times x minus 8 times log of 9 equals 3x minus 3. Then you're going to get the x's together, so it's 9 log of 9x, or log times x. And I'll subtract 3x from this side, and I'll move this over to the right side, so it'll be 8 log of 9 minus 3. And then I'll factor out the x's. It's 9 log of 9 minus 3 equals 8 log of 9 minus 3. And I'll divide by this number. And there's your answer. I know that's tricky, but you can do this in your calculator and enter it as a decimal, and that will work just fine. Alright, the next one I divide both sides by 4, and you get this. Then I would probably take the natural log of both sides. That cancels this. Actually, better yet, let me back up. I would actually divide both sides by e to the 0.85t. What I was doing would work, but this way is better because when you divide both sides by this, then you could subtract the exponents here to get this, because when you have like bases, you subtract the exponents. And then you can divide both sides by 5, and then you can take the natural log of both sides basically, and you get 1.15t equals natural log of 4/5, and divide both sides by 1.15 to get your answer for t. Okay, the next problem, I would change this into log form by doing log base 3 of square root of 3 equals negative 2x plus 5, and then just solve for x. So you have log base 3 of the square root of 3, subtract 5 from both sides and divide by 2. And there's your answer. You can do that in your calculator.